Hi, welcome to the exercise of the lecture 2 about elimination reactions. Okay, we will start by the exercise number 1 that basically says that we have to do the curly arrows in order to show which is the result of the following reactions. Okay, this is elimination, it's a E2, that means in A2 everything happens at the same time. Okay, this is the leaving group. Okay, and then we have to localize a hydrogen that is 1 carbon away. For example, this is 1 carbon away of the carbon has the leaving group. Okay, and we can choose this or we can choose this, but are symmetrical. That means that it's the same. What is happening is that the base is taking the hydrogen, the pair of electrons between the hydrogen and the carbon are forming the double bond, and the leaving group is departing to generate this final product. Okay? Check that if we do it with this hydrogen, we will get exactly the same. Okay? Second example, we have the base, and we have here the compound that will undergo the elimination. Here is the bromine. We need to find a hydrogen 1 carbon away. Here, in this position, we don't have any hydrogen. We have 2 methyls. That means not possible. The only hydrogen that is possible is here. And again, it's A2, only one step. Okay, the methoxide is taking the hydrogen. The pair of electrons, hydrogen, are forming the double bond, and the leaving group is departing to form this compound. Okay? Last one is a little bit more complicated. We have the base, the thermotoxide, and we have this bromine. And now what we saw is that we have 2 possibilities. This hydrogen here, or this hydrogen here. This position and these positions, again, are symmetrical. That means that the thermotoxide will take, for example, we choose this proton, taking this proton is doing the double bond, and the leaving group is departing. And what we have is this final product. But however, also we can have that is taking this proton. The thermotoxide will take this proton, the pair of electrons between the carbon and the hydrogen are forming the double bond, and the bromine group is departing to generate this final product. That means when we are doing this last reaction, we will get 2 possible products with the double bond here or the double bond into the cycle. Okay? Again, always we have to check the hydrogen that is 1 carbon away. Could be more than 1, and then we will have a mixture of products. I will never ask which product will be majority. This is for advanced courses. Okay, but you have to know that we can have more than 1 product. Okay, number 2, what they say is that we have an E2 elimination and we have this compound. Okay, and we are doing a E2 using as a base sodium hydroxide. What will happen? Okay, first of all, we need to draw the transition state. Okay, because it's A2, we will have a transition state. And what we know of the transition state? The transition state requires that the leaving group, the bromine in this case, and the hydrogen 1 carbon away, it's the only hydrogen that is one carbon away. Here, this carbon doesn't have any hydrogen, and here is the only hydrogen. These two groups has to be in antiperiplanar. What means antiperiplanar? One up, one down. That means I have to draw this in the way that the bromine is down. I don't move the bromine. It's okay. Okay? And then I have to put this hydrogen up. I rotate this, I put the hydrogen up, then the methyl is coming in front, okay? And the ethyl is coming inside the slide. Okay, this is the transition state. This is the right conformation to draw the transition state. What is happening is that we have the base, okay, and the base takes the hydrogen, the pair of electrons that are forming the bond carbon-hydrogen are forming the double bond, and the bromine is departing, taking this pair of electrons. And then the only that we need is to apply that the substituents that are in the same side or the same face of the slide, in this case a whiteboard, are in the same side of the double bond. We draw the double bond, okay, I put here the ethyl, here the methyl, and then which group is at the same side or the same face of the methyl? In the case of the methyl, the one is in front of the slide. That means that the hydrogen also is in front of the slide. Here we will have the hydrogen in the same side of the double bond. Obviously, the ester will be in the same side because it's behind the slide, behind the whiteboard, than the ethyl behind the whiteboard. Okay? Easy. Remember, in A2 we have a transition state, and the transition state requires that the two groups that are leaving, whatever they are, in this case the bromine and the hydrogen, must be in antiperiplanar. The conformation to take place, the transition state, has to be antiperiplanar between the two groups that are departing. Okay? And then, when we draw the right conformation, with the bromine down and the hydrogen up, or if you want the bromine up and the hydrogen down, the only that we need to check is which groups are in the same face of the slide of the whiteboard. Groups that are in the same face of the whiteboard will be in the same side of the double bond. Okay? Good. We go for the next one. The next one, we have this compound. And what is happening is that we have E1CB elimination. Okay? What means E1CB? Remember, E1 is the leaving group departs first, and after a while we have the losing of the hydrogen, the proton. E2, the removal of the proton and the losing of the leaving group, the departing of the leaving group, happens at the same time. And in the case of E1CB, what is happening first is that we take the proton first, and after a while the leaving group will depart. Okay? Which proton we have to take? We have to take a acidic proton. Which of these protons are acidic? This proton. Why this proton or this proton? Why these two protons? Because basically, when we take the proton, we generate this base, this enolate, okay, this compound, this carbon ion that is stabilized by resonance. And why we choose this hydrogen and not this hydrogen? Because the leaving group is here. We need the leaving group 1 carbon away of the hydrogen, or just the opposite. We need the hydrogen 1 carbon away of the leaving group. Okay, that means that the first step, we take the hydrogen and we form the enolate or the carbon ion. That, remember, is in equilibrium with okay? And then, after a while, what is happening? This is the first step. Second step, we form, with the negative charge, we form the double bond, and the leaving group is departing. In this case, basically, okay? You can do whatever you want of the resonance forms. I recommend this because it's easier, and it's more clear that the negative charge is in the carbon, okay? And what we got is this compound. Okay? If you do this is exactly, with this resonance form, it's exactly the same. We will get the same. Okay? And the last one, they say that we have this compound. Okay? And we are getting this heating at 65 degrees, and they told us that we have an elimination, okay, and which are the different products that we can get. Well, we have here the leaving group, okay, and then if it's an elimination, we have to find the hydrogen that is 1 carbon away. In this position, there are no hydrogens, there are only free metals, and the only available is this. Okay? The hydrogen that is bonded to this metal. Because we are not using base, basically we can suppose, and because the stabilization in this position is very good, because we have a benzyl ring, we have a metal, it's a tertiary. What we will get is an E1, I will propose to get an E1. Okay, and then what we get is, remember, E1, the leaving group is departing, we generate the carbocation, as you can see here. The carbocation is very stable, it's a tertiary carbocation. Okay. Sorry, my cat. He likes to learn chemistry. Okay, we have the carbocation. And now what is happening? We have the carbocation, and if we are doing an elimination, basically, the only that can happen is that we have the hydrogen here, and basically we generate this product. Okay? But in this exercise they say that we have a mixture of products. What could be the other product? Okay, we do the elimination, but remember, this is a carbocation. What we can have also is a substitution. That means we have here methanol. What could happen is that the methanol will attack the carbocation, and what we get is simply the addition of the methanol to this position. This is by E1, and this is an SN. SN. Okay? This is the answer. The important thing of this exercise is that it's A1. We have, if it's A1, we have an intermediate. The intermediate is the carbocation that we generate after the departing of the leaving group. And from this carbocation, remember that it's the same intermediate by E1 or for SN1, we can have the elimination with the hydrogen that is one carbon away of the carbocation in this case, or we can have simply a substitution that we learned in the first lessons, in the first lecture. Okay? Thank you very much. Sorry for the cut, and see you soon.